Okay, so this is my homework, finding the equation of the line along the intersection of two planes. So I have plane 1 here, which is 3x minus 2y plus z equals 5, and I've got plane 2. I've done the cross product of 3 minus 2x and 1, and 1, negative 1 and 2, and that gave me this answer, which is minus 1 in the I, minus 2 in the j, minus k. So that is minus I minus 2j minus k. Had I swapped the order around, I would have got I plus 2j plus k, which is actually going in that direction. I plus 2j plus k. Either of them is acceptable because they're both going in the direction of the line across the intersection. So I'm going to take the one with all the positives. I'd like to find a point on the line, or I'd like to express y in terms of x and z, and x in terms of z, or z in terms of x, to be able to come up with the equation. So I've got this. I've rearranged for y equals. I've rearranged for y equals. Then I've set this equal to this and rearranged for z equals. So I'm going to say that one of the points is when x equals 0, which means x plus 3 is z, so z equals 3, and 0 plus 3 minus 4 is y equals negative 1. So that gives me the point 0, negative 1 and 3. A point on the line, that's the direction of the line, or that's the direction of the line. So I would have acceptable answers of r of t equals negative j plus 3k plus t minus I minus 2j minus k, and that's perfectly correct. Or I'd also accept minus j plus 3k plus t, I plus 2j plus k. I'd accept any vector parallel to this. I'd also accept minus j plus 3k plus t lots of 2i plus 4j plus 2k. All three are perfectly acceptable answers. The other thing that I could do is, instead of having this parameter t multiplying the direction in the form of a plus td, I could say that r of, let's use the parameter lambda, that equals, let's call x equal to lambda. It's going to be lambda in the I plus those z will equal 3 plus lambda. So plus 3 plus lambda in the k, and y will equal lambda, because x is lambda, plus lambda plus 3 minus 4. So that's 2 lambda minus 1. 2 lambda minus 1 in the j. That's also acceptable. Now keep in mind that if I was to put this all in terms of something plus lambda times something, I would have I. The j's would give me a minus j and then plus 2j times lambda, and the k's would give me plus 3k, and that's going to be plus k. And that's the same answer as that answer, using not the parameter t, but the parameter lambda. Now, that gives you 1, 2, 3, 4, 5 possible answers that are all acceptably good. Now, had you have arranged these differently, and had you have arranged it in terms of, you could have made z lambda. If I had made z equal to lambda, then x would have been lambda minus 3 and y would have been, where are we, y, z plus, so x is lambda minus 3 plus lambda minus 4, is that correct? Yep. Which would be 2 lambda minus 7. So I would also accept, let's use beta instead of lambda. So x is beta minus 3 in the I plus 2 beta minus 7 in the j plus beta in the k would also be an acceptable answer if we rearranged and made our parameter equal to z, then I rearrange what the others would be. If you want to put it in the forms of plus beta times something, then it's going to be a, it's going to be plus 2j, and that's going to be I, and this would be 3 in the negative 3 in the I minus 7 in the j. This is a different point on the line, so the point negative 3, negative 7 and 0, negative 3, negative 7 and 0 is also on the line, and lo and behold, that is the same direction as that one, and it's parallel to all the other ones. So we have two options. We can choose the parameter and put it into i's and j's and k's, don't always have to use t, or you can put it in the form of a point plus t times the direction, or a point plus beta times the direction. Lots of choice. I'll accept any of them as being correct. Hope that helps.